This is part 4 and the final video in a series of tutorials about how to make this parametric facade. In today's video we'll look at how to finish this facade using Dynamo and all the families and elements you made in previous tutorials. So let's start by opening a family we made in previous tutorial, the 4-point adaptive family. Open category and parameters panel and change family category from generic model to content panel. Now load the family into the project we made in the first tutorial. Also load the families we made in the second video, 3-point adaptive and 5-point adaptive panels. This is the facade we made in the first tutorial, and maybe we'll use Dynamo to populate this facade with 3-point, 4-point and 5-point adaptive panels. This is in-place mass with divided surface, populated with rhomboid curtain panel family. And this is the family that we will need to select and replace using Dynamo. Rhomboid curtain panel. So how do we do that? Let's start Dynamo. Now select new file. Right click and type family and select family types. Then click on select drop down and select curtain panel rhomboid. And now we need to set Dynamo to run manually, not automatically. Now right click again and type all elements of type. Select all elements of family type. Then connect those two nodes and run. And when you run, you can see the list of all the selected curtain panels. Now again right click and type element dot face. And this node will select only the face of this family that we're after. Now when we run, we can see that all of the faces of family curtain panel rhomboid is selected. You can switch 3D view and check if all the faces are selected. Now let's put this down below so it doesn't interfere with our workspace. So what next? Now we have all the element faces selected. It's a good practice to put data gates so you can control the data flowing through the Dynamo graph. So later you can open and close the gate to various graph groups. In that way you can run Dynamo faster by just testing some parts of Dynamo graph. Okay, now we need to select the surface parameter of the selected surfaces. So right click and type surface.perimeter. Okay, let's move this down. And now when we have selected perimeter curve, we need to count how many points there are. So right click and type curve endpoint. Select curve endpoint. And this will show how many points are there in the selected curves. When we run, okay, we can see that the gates are closed. Open gate, and now you can see that the surface has perimeter curves and endpoints selected. Now we need to count those points. So type count, list count, and run again. And now you can see that we have 255 points, but that is not the number we're after. So select use level, level second, and now when you look at the data, you can see that we have a list of 4, 4, 4, 4, 5, 5, 5, and 4 and 5 points. So we need to check if there is any 3-point panels. And we will do that by right click and type equal equal, select equal to 3, double click and type 3. X is equal to y, and it will return false or true statement if x is equal to y. So we can see that there is no true value. But we will double check that by adding a filter by bool mask. Just filter by bool mask. Okay, it's down here. Select that and connect mask to bool and connect point list to the list of filter. And then when we run this again, we can see that let's add watch node. We'll connect this to in, run again, and we can see that the list is empty, so there is no in values in the filter. There's only out values, which are false. So there is no 3-point panels in our divided surface. Here you can see that there's only 4 and 5-point curtain panels. Okay, but we will select all of the nodes, press Ctrl G to group them, and rename the group to 3 points. So if your facade have 3-point panels, you can use this group to select them. Now select the group and drag, and then press Ctrl to copy the whole group. This will be our 5-point panels. We need to change this to 5, and now it will select the panels with 5 points. Let's add watch node. Let's run. There's an error because the gate is closed. Open the gate and let's run this again, and here you can see that we have our 5-point panels selected. There is the list of 5 points. 1, 2, 3, 4, 5. Okay, great. Now we need to add those adaptive panels to those points. So let's right click, gate. Okay, another gate. Actually, we don't need the watch here. Just the gate. Right click again and type adaptive. Select adaptive by points. Connect this to points because these are 5-point lists. Type family and select 5-point adaptive 5 points. Connect this to family type. Let's select and add to group. And now open the gate and run. And after a while we see that the project is populated with 5-point panels, just in the places where they are in the divided surface, on the top, on the bottom, and on the sides. That's great. Let's go back to Dynamo. Let's move this gate down to the side. Now let's save the model. Let's select the group at 5 points, and when you drag, click Ctrl to copy the group. Let's move this down. Actually, we don't need this gate, and rename this to 4 points. Now open the gate, change this to 4. Let's leave this gate closed for now and run, so that Dynamo doesn't try to put 5-point panels in the 4-point lists. Let's change this family type to 4-point adaptive panel. Let's open the gate and save the model because it might crash. And let's run. And after a while, the project is populated with 4-point adaptive panels. And we can clearly see that something is wrong. So that's okay. So let's rotate the view and hide the surface. And we can see that the panels are on the wrong side of the surface. That is one mistake, and something is wrong with the geometry. So select edit type and let's change the depth of the family. This will change the depth of all the panels because this is type property. Okay. Now let's go back and see that there's still some issues. Let's select one of the panels and change the instance parameters. Let's see, one or more of the values are wrong. Let's set offset back to 200. Great, the panel is fixed so that the offset back was too large and it couldn't calculate the geometry in the family. Okay, so let's go back to Dynamo and we need to set this parameter for all of the panels. And we need to set the panels on the other side of the surface. So right click and type list.reverse. This will reverse the point lists. So it will set the adaptive component by points in the other direction. So what do I mean by that? Let's add watch node to the filter bool mask and close the gates for other groups so the dynamo will run faster. Let's close this and that. Okay, now let's run, and we can see that this is our filter by bool mask list. Okay, let's move this down. Okay, now let's copy the watch node, drag and control, and connect the reverse list to this watch node. Run again. Here you can see that the list is reversed, and this is not what we need. You can compare two lists. Here you can see that this is the beginning of the filter by bool mask, so we need to use levels again. Let's set to level 2, run again, and now the list of 4 points are reversed, and this is exactly what we need. Okay, let's delete those watch nodes. Let's move this up. Okay, right click and type element set parameter by name. Okay, now connect this adaptive component to element, right click and type fillet. No, we need string node. Okay, type string and type offset back, and connect this to parameter name, double click and type 150, and this is our value that we want to set for all of our adaptive component families. Open the gate and run, and after a while you can see that all of the panels are fixed and in the right side of the surface, and there is no more issues with the geometry. So basically we have all the adaptive panels placed on this surface, and all we have to do now is tweak some parameters so that they change in the way that we like. Let's say on the bottom the value for offset back will be larger and the hole will be smaller, and on the top the offset back will be smaller and the hole will be bigger. So let's go back to Dynamo and add those parameters. First thing we need to do is get the locations of those adaptive points. So right click and type adaptive components and choose locations. Adaptive component locations. Here is locations. Now join these two nodes together so that we have locations for those points. Now we need to get average value for those points. Type point.z and connect these two nodes together. So now we have the locations for those points on the z-axis, and now type math average and we'll have average value for those 4 points for every panel. Let's select and group them and type average z. Okay, let's move this up and let's move this to the side. Okay, and now we have to remap the math average value. Type math remap, and we have to remap this average z location value to the values we want to add to this offset back parameter. So we need the minimum and the maximum value. Right click and type number, and the minimum value will be, let's say 280. This is the minimum value. This is when the panel will be closed. Duplicate that and type, let's say 150, and this will be the maximum value, so that on the top the panels will be open, on the bottom the panels will be closed. Connect this to value on element set parameter by name node, and let's move this up and we can group these nodes together. Smooth this down a bit. Okay, we don't need this code block. Select all, Ctrl G, group, and type offset back. This will be group for offset back parameter. And now we can run this graph. Press run and wait a little bit. Let's minimize the dynamo, and we can see that there is a slight problem in the lower part of this facade, and that is because probably the parameter for the offset back is too large, and the family cannot calculate the geometry. So if we type 250, seems like it's still too large. Let's change it to 220, okay. And now it should be okay. No, it's still not enough. Let's change fillet back. It's probably too large. Value here, 150. Okay, that's great. So we need to change fillet back and offset back. Let's change this back to 280. And let's see. Oh, no, there's still an error. So let's lower the fillet back value to even less. Let's say 100. Okay, now it works. So we need to change fillet back and offset back. Offset back, let's leave that at 280. Let's Control copy this, and we'll change this to fillet back. So we need to change the maximum value of 100, and the minimum value will be 150. So let me think. The minimum value, let's say 100, just to be safe, and the maximum will be 150. So the maximum value will be on the top, and the minimum value will be on the bottom, where the offset of the back is greater. Okay, so the 280 is in the bottom and 150 is on the top. And let's change this to 80, just to be safe. Okay. And let's change this to 100, just to be on the safe side. Okay. Let's open this gate and open this gate so we can populate the whole geometry. Let's save and run the graph. And after a little bit of waiting, we can minimize the dynamo, and yeah, here we go. This is exactly what we wanted. On the top you can see that the holes are bigger, and on the bottom you can see that the holes are smaller. And basically you can change all the parameters just by this example, just as you like. Let's say you can change the fillet on the top, like let's say to 250, and no, that's too big. We also need to change the fillet on the back to 250. Okay, that's better. Let's see what else we can change. Let's change offset back to let's say 150. Now this looks much better. Let's see. Yeah, I like this. I like this shape. Okay. So let's add this to the dynamo graph. So we need to change the new maximum value of 150. And let's rename this to fillet back. And we need to change also the fillet front. Let's rename this to fillet. And let's see what the values were. On the bottom we have fillet of 150. No, that's, and on the top 250. So okay. So this max value will be 250, and the minimum value will be 150, and change this to fillet. Okay. I think we're all good. And if you see this Dynamo is not available, just switch to the, let's say, plan view. This is some kind of bug for Dynamo, I don't know what. Let's run this graph. And let's see. Okay, great. This is exactly what we needed. Let's check those values. 280, 180, okay. Let's see the top one. It seems okay. So now we can turn on the smooth lines. Graphic display options. And then we can change the eye elevation, I think, to the same level as target elevation. Let's say 3000. Okay, cool. And I hope you learn a lot about Dynamo, about adaptive families, and about how to make parametric families. So have a great day, save the model, and see you in the next video.